WarsawJS.
Alrighty, so my name is Michał Miszczyszyn. At Type of Web is my Slack/nickname almost everywhere now. It was kind of a bad decision to change my Twitter username while we were in the Silicon Valley. So some people couldn't follow me, so some of them couldn't find me for some period of time. But now, yeah, it's all good. I'm Type of Web everywhere on GitHub and Twitter, and my email is at typeofweb.com. So you can find me by this nickname everywhere. Either way, I will be talking about the property-based testing today. And property-based testing is the special kind of testing that you rarely really hear about. So I want to start with outlining the problem that we are trying to solve. Like it's not like it's not just about quality. It's not just about testing things, because you can use that the testing framework that you know already to do those things. So what is the problem with testing? The problem with testing is, this is not the problem, this is the value. The value of tests is that they help us verify the correctness. But, and I think everyone agrees that they do. I mean, it's hard to imagine starting or writing any larger IT project without tests. It would be hard to bear, it would be unmaintainable. And the tests usually consist, and I think this is the case for almost every framework. They consist of three main parts, which is conditions, changes, and observations. And sometimes you call these parts given, when, then. All assumptions, actions, assertions. Either way, you usually have the part where you set up the test, then you have the part where you do some actions, and then there's the part where you test if the state of the application is what you would expect it to be. And I believe that the problem is that developers are responsible for all three parts of writing tests, or the QA engineers, or whoever, just basically humans. And I know you have a lot of AI tools nowadays, AI is on the rise, that help you do that, which is great. However, I think the problem remains that it's still the human that needs to initiate the process and need to think about the scenarios that are required for the application to work. So the question I always ask is, can we actually prove correctness of any application using using any technique? And the answer is usually not. Because if your application is simple enough that you can mathematically prove it is correct, then there is no point in testing it anyway, usually. And in any more complex cases, you probably cannot mathematically prove that it is correct. And therefore, any testing framework cannot guarantee that your application is also correct. By the way, we are building this thing. This is like the 30 seconds for advertisement. I change this slide like on every meetup. When I do this presentation, I change this slide and I talk about next project that we are working on, because we like this idea of failing fast. So we fail every 2 weeks and start something new again. Either way, we are building yournextstore.com. It's actually getting some traction. It was on Product Hunt. It's where we are working with some big names on it. So I highly recommend to check it out. Either way, property-based testing, back to the topic. Property-based testing, it's, like I said, the problem is that I believe the problem is developers are responsible for writing all three parts of tests, which is assumptions, actions, and assertions. And in particular, the problem is with actions, in my opinion, because we can quite easily imagine the state of any application at the beginning, like when we open the application, and then we can probably imagine what the state should be by the end of our testing. It should be, well, correct, should be working, should be not failed. But what kind of actions can we take within the application? This is the problem. And property-based testing is a different approach to testing. It's an idea that comes from Haskell, from a framework called QuickCheck. It was later refined in Elixir. It's also implemented in Rust, in C++, and in many different languages. and finally in TypeScript by the name of fast check. However, the idea is that the inputs to tests are randomized and they are constrained. And we think of properties and not exact assertions. And what does it really mean? So let's look at an example of a unit test. Sometimes unit testing is called example-based testing because we only test a single unit, which is an example, which is an edge case that we could have thought of. And let's give the simplest possible example that you will probably find in most of the presentations about property-based testing, which is testing sorting of a list. So we have an array, we have a list 3, 5, 1, and when it is sorted, the result is 1, 3, 5. So we have one unit test, we have one example, we have one edge case tested. Let's say the test passes. But how many other unit tests like this would we have to write in order to get even close to being like feeling that we are certain that the application is working? And this is a problem that's easily solved by property-based testing. However, reasoning about the test then is much more difficult because instead of listing examples or test cases that we want to test, we are thinking about properties that we want to test. So what kind of property does every sorted array of numbers have? I would say that, for example, each element is greater than the previous one. So when we have a list of numbers and we sort it, then each element of the list is greater than the previous one. There are a few other properties we can test of. So for example, that when we have a list and we sort it, then the length of the output list is the same, remains unchanged. Other property could be that each element from the original list occurs in the output list, and it does it the same number of times as in the original list. So this is basically what property-based testing boils down to. We have to think of properties, then we write those properties using a framework, and then we test those properties. And the framework helps us generate randomized examples of the code. But does it work in real life? Well, kind of. In property-based unit testing, so what I just showed you, in my opinion, it's just a fun exercise to change our reasoning, but often it's more complex than the underlying implementation, so it doesn't really make any sense to do that. But where it makes sense is property-based integration tests or property-based end-to-end tests. Because when you Google property-based testing or try to find it on YouTube, most of the presentations end on unit testing, and then they show you a simple example and they say, okay, you're done. You know everything you need to know. Now just apply it to more complex problems. And it doesn't really work that way. So I would say no to property-based unit tests like this, but property-based end-to-end tests, this is really curious. So let's look at some examples. Google LevelDB is open source database. They using, I think it was written in C++, so they were using something like quick check, and they were able to generate test cases consisting of 17 steps and 31 steps that actually led to corruption of the database. So can you imagine finding like a QA team or developers finding and reproducing and writing down a bug that consists of 31 consecutive steps? Because I cannot. I mean, it's hard with 2 steps, and 31 is like hard to even imagine. And then Spotify, they had a UI bug in their playlist, also written in C++. They had the UI when you added something to the playlist and then clicked next and then clicked something and then added again and clicked play. It started playing wrong track. It's not that big deal, but funnily enough, it was not discovered by the QA team for years until they started using property-based testing. And this is actually very well described on their blog. They have a long article about this. So how do you do property-based testing in case of end-to-end tests? So you still have randomized steps. However, in parallel to your application, so like that the big box is your application. It's a real app. You also build a smaller box, which is a simplified model, which represents everything that happens or you think should happen inside your application. So it's really complex because you have to maintain two implementations. One is the model and the other one is the real application. However, the simplified model is stripped of everything that is not necessary to perform testing. For example, and it's just an example, every operation inside of the model could be synchronous. For example, we can ignore HTTP requests, we can ignore delays, we can just simplify to the bare bone problem that we are trying to test. And then we compare the state of both systems when the state is stable. And it's actually really simple to implement that on the front end as well, using TypeScript and using Playwright, which is what I'm about to show you in the code. Oops. There we go. Okay, so I've built this application. I've built this application. This is like it's supposed to be a copy of Spotify, except mine is pretty and Spotify isn't. And it's using, no, I basically implemented just one feature for the sake of this presentation. However, you can imagine that this is a real application. So we can actually play songs. Let me make this a little bit bigger. You can see at the bottom that it's playing. You can change tracks. There are other tracks on, like in my library. I can add it. I implemented this feature where you can add, for some reason, the track to the beginning, middle, or end of my playlist. So let's add it to the end, and it's added. Okay, so it seems to be working just fine. So then I started writing, and it's just React. It's only the front end. There is no back end, really. So I started writing property-based tests for this. And let me show you how it works. So let me. So what we have here is, apart from the application, you also have to maintain, like I said, the simplified model. So what is it? Basically, the simplified model is the set of operations that I can take in my application and its state. In my case, it will be, this is even unnecessary, I guess. In my case, the state is just, is anything playing at all? Or how many tracks do I have on my playlist right now? It could be much larger, but like I said, we have to try to minimize it to the bare bone minimum of what we are trying to test. So we have this model, and it's a class, because this is what FastCheck requires us to do. It has to be classes. And then we have a set of operations that we can do. So for example, we have the play command. What does play command do? The commands always take two arguments. One of them is my model, and the other one is the real player. My model is basically the instance of the class that I just showed you, and real player could be a function or a class that actually does real operations using Playwright on a running app. So when I call await p.play, it actually calls Playwright, opens the browser, enters the application, and starts playing something. And in case of my model, I just mutated very dirty. I just said that the playing is true, and and then I assert whether the state. It's kind of obvious right here, but it's just for the sake of simplicity. I just assert that the is playing and is playing on both is true. So having said that, we have a few operations. We have the model, we have a play, pause, next commands, and then we have a test. But I won't show you probably pointless to show you the code because, well, it's just a test. It doesn't really matter the syntax. However, what I can do right now is I can actually write those tests. And to warn you, I've introduced a bug in my application on purpose. It's not that easy to spot it. As well, I was clicking through the app, it was working, but there is a bug in there. So when I run this, we can actually, I added some logs, so we can actually see that there are randomized actions being taken. So for example, in this case, FastCheck is trying to play, pause, play, next, add a track, and so on, and so on. So it's actually generating like tens of different test cases, and finally it fails. So we can see some additional debugging info, but also see where it failed, after what kind of operations did it fail. So it tried to click next, then it added a track to the beginning of my playlist. And that's it, just 2 steps. Simple enough, right? And we also have the like I said, the debugging information, but it can also be used to replay the exact same test without any randomization. So if I just provide these arguments, there won't be any randomization, and I will be able to, for example, retest the same run on another machine, or maybe with my colleague or something. However, what's also interesting is the fact that I guess, where is it? Yeah, there is this. The log said something like shrank 5 times. I'm not sure if everyone can see this, but what does it mean? It means that FastCheck actually found this bug after performing many more operations than just 2. And then it tried to minimize the required steps to reproduce the same problem. So for example, we can probably guess that it started failing somewhere around here. So it was next play, next, add track. And then it tried just add track, didn't work. Then next, add track, probably failed. Then next, add track. And tried a few other combinations, and it's inferred or it thinks that the minimal reproduction of my bug is these 2 steps, next and add track. So this is very powerful. We can disable it. We can track all these steps. We can see exactly what it's doing. But it's really powerful, the fact that it minimizes the steps taken automatically out of the box. So we can see if we can fix the bug. Let me see. Where is it? Is PS. Oh yeah, true. Okay, so let's see, because funnily enough, it might happen, might not happen. This is the problem with randomized tests. This code base might still not work correctly. However, the bug that we just found out is fixed. Let's run pm test again. And we can see that it's taking many more steps now, generating many more test cases because it didn't find the original bug. However, this happens from, this is not the first time I'm presenting this, but I still haven't fixed this on purpose. The first time I presented this, I was kind of shocked during my presentation when I ran the tests, and I was expecting it to succeed, but the test failed again. So actually, when you do play next, up track, then it fails again. So there is another bug. I never intended to introduce this bug. I just implemented it. I thought it was right, and FastCheck found it for me. So I think this maybe not proves, but it definitely shows that it's very useful too. Alrighty. That would be all for today, but you can find the same like content or the introduction to this content on my blog at typeofweb.com. I've written an article about this. Part 1, part 2 is coming soon. And find us on yournextstore.com. Thank you.
Was that magic or what? Well, yeah, it was pretty much magic. Okay. Does anyone have any questions for me now?
Sorry, I might have missed it, but what's the actual like library? What's the actual underlying library implementation for the optimization?
Okay, so just for the property-based testing is FastCheck, and I also using vtest and Playwright. in this case.
Okay. Can we test React apps with it? Now, I'm not asking if we should, but if we could.
Yeah, why not?
So you had to build a model that was reasonably simple and pure and only contained state and commands. So if you already kind of have that, do you always need to build another one? Or can you make do with just one model and assertions?
So I'm not an expert. However, it makes a lot of sense. If you are following the MVC principles, then you probably can reuse the same model. It makes a lot of sense to me. The approach that I showed you, actually, it's based off of the Spotify article. So what they did. Also, the added bonus of it is that you can have the implementation of the application in a different language and then write tests in a completely different language if you wanted to.
Okay, thank you. Amazing talk. When we are speaking about integration or end-to-end tests, there is also, like, I guess most painful problem is flackiness.
Yes, generally introduction of property-based testing introduces flackiness of your tests because then each of your tests is randomized. So like I showed you today, my test failed by the end of the presentation, but 3 times previous it didn't. So yeah, you have to take extra measure, like maybe repeat the runs. And in case of property-based testing, the first thing what you do whenever you find a bug should not be to fix it. It should be to rewrite this test case as a standalone unit test or integration test, so that you repeat the same test every time you run your tests.
Once again, give him a big hand, everybody. Michał Miszczyszyn.
WarsawJS